Welcome back, everybody. Welcome back to another Stig shift. And this shift is going to be a bit unusual because honestly, I did not get to capture much of anything. The reasoning for this is because I simply did not have a chance to capture any footage because we were so busy. The weekend shift was not the only busy part of my schedule because after I got done working within the weekend, I also had to fly down to Dallas, our headquarters, for some training. And on top of that, when I got back from Dallas, we had scheduled tours with a local A&P college to give the students a look-see on what we do as a daily basis with an aircraft maintenance environment. As you can see, I've had a pretty busy week, but I did get to capture a few things that might be of interest to you. A lot of eye candy of airplanes taxiing by and taking off, which you'll see right here. But there was one particular scenario that did come up with one of our Airbus 321 Neos, and I had to address the situation and the troubleshooting tactics behind it. And it's going to be a bit of a hosh-posh of things because I'm going to bounce back and forth between different systems. Let me give you a little bit more context and explanation. You're going to see the aft unpressurized compartment where the jack screw lives, as well as the horizontal stabilizer. And then we're going to get back to the aft cargo pit where the actual problem was. So stick around if you want to look at that. We're going to look at some pretty airplanes taking off, and then we're going to get to the actual issue. Here's our aircraft in question. This is our beautiful Airbus 321 Neo. She's pulling up, and the flight attendants had reported a very specific and interesting problem. The problem is noise, and the noise is coming from the aft galley portion of the aircraft. The flight attendant reported that it is some kind of a rumbling or knocking noise underneath the ground or behind the galley compartment. After doing preliminary checks, making sure everything's okay, and making sure it's not the chiller that's actually making the noise, now this becomes some kind of a mystery. Now we have to go discover what is actually happening. And to be honest with you, this is actually the real fun part of the job when it comes down to true intuitive nature of the troubleshooting tactics. This is the kind of stuff you won't find in manuals. This is the kind of stuff that comes from experience. You see, when there's a fault, there's usually a code attached to the fault. But when you're starting to troubleshoot something or a system from simply a sound, now your intuitive nature has to take over. You really need to understand what the aircraft is doing and what the components are behind the walls. So, that being said, my knee-jerk reaction or my instinctual reaction is to go to the most critical items, flight safety items, whatever is behind the galley wall, which is the unpressurized compartment. And here we are. Big dome looking thing is the aft pressure bulkhead on the Airbus 321 Neo. Once again, my initial thoughts went directly to safety of flight and the most critical items. And anything behind that pressure bulkhead, which you're seeing here, are these components. These are the pressure safety valves. A bit more context on what I got from the flight attendant and the turnover or the report from the flight attendant was that the noise started emanating on takeoff and it stopped right around 20,000 feet. So this is why I'm here. My initial instinct reaction is some kind of a pressurization issue. The primary purpose of these safety valves is to prevent the pressure within the fuselage to get too high or too low. The valves themselves are a poppet style pneumatic valves. They consist of a aluminum housing with a spring-loaded diaphragm. The diaphragm has a gate and a deflector with a built-in check valve. The chamber within the two sides of the diaphragm have access to the cabin pressure through the holes. That's the fancy way of saying if there's too much pressure inside the airplane, these valves will open up and release it. If there's not enough pressure inside the airplane, these valves will open up and let pressure back into the airplane. But Stig, how does it know how to do that? Because it has a pneumatic controller assembly. It also has a position switch. It's also talking to the pressurization systems of the aircraft. The safety valve will open at a differential pressure of 8.6 psi within the cabin. The safety valve will also open at a negative differential pressure of 175 psi. Okay, back to the troubleshooting tactics. This is why my initial thoughts went to this. I wanted to take a look at the safety valves, making sure there's no breach within them. Because if there was a breach within them, you would hear some kind of loud noise within the aft cabin. After inspecting both of the safety valves, there were no issues with them at all. They were perfectly sealed. Everything was functioning good on this. So we got to move on. Since I was here, now I start looking at the rest of the components over here, such as this right here. These are the primary electrical connectors coming from the APU generator going into the aircraft. Remember, the APU has its own generator that is producing power, needs a way of sending that power into the aircraft, and it's via these cables. They are going through the pressure bulkhead. Now, a common question that I always get asked is, how does the aircraft maintain pressure when you have components or lines like this going through the pressure bulkheads? The simple answer is they are going through very particular seals. As you can see with the riveting around that area, it is very heavily reinforced. This is the same concept when it comes down to, let's say, a 737 and cables running through the pressure bulkheads. They have grommets and seals that cover that pressure source. Now, granted that any kind of seal is subjected to seepage, just like any kind of hydraulic fluid. But the aircraft pressurization system is very powerful. It's strong enough to maintain the pressure within the aircraft, so it does not affect the pressurization. To be honest with you, if you want to go down the rabbit hole of pressurization in aircraft and how it works, every single time you flush the toilet on an airplane, you are actually depressurizing the airplane by like minute amounts, like 0.00 something. But yeah, every time you flush a toilet within an airplane, it's using differential pressure to suck out the waste and let it go into the waste tank. But overall, yes, that's what you're doing. You're depressurizing the airplane. I'm just trying to make fun of this situation or this scenario. Even if you have a continuous flushing toilet and it's doing all that, continuously flushing and opening that valve, the airplane is strong enough, or the pressurization system is strong enough to continuously keep up with the pressure of the cabin. I'm just trying to give you context with this. Okay, moving on. As you can see, the orange lines are running through the aft bulkhead and going to the aft section and getting its power source from the APU. Now we run into this silver pipe right here. This is the pneumatic source from the APU. It is a pipe that is directing airflow into the aircraft, not only for aircraft air conditioning systems when the aircraft is on the ground, but it's also supplying air to the engines when the engines need to start for this aircraft. A quick little side note to my future aircraft mechanics: if you are working within this compartment and the APU is running or has ran and the pneumatic systems have been active, please do not touch this pipe because it is extremely hot. Another source of sound could be coming from this pipe, because within this pipe, throughout the belly of the aircraft, has a check valve, which we call the clapper valve or a butterfly valve. What it does is prevent reverse airflow from the system within the aircraft back into the APU. But that wasn't the case on this one. The noise was not coming from the little clapper valve. We're going to keep on trucking over here, and I'm going to go a little bit off the rails and explain a few different systems because I have the opportunity to. So Airbus is very much known for being a fly-by-wire aircraft, but there are still cables available within particular systems. The system that we are looking at right now is the THS, the Trimmable Horizontal Stabilizer, as well as the systems for the rudder control. Now, with the modern day and age Airbus 320 family, there are 3 sets of cable available to this aircraft. One for the THS, the Trimmable Horizontal Stabilizer, which you're looking at right there. Another one for the rudder cables, and also cables for the landing gear manual gravity drop, which I've shown you before. When we do heavy C checks and D checks, we are checking these cables and we are performing tension checks, making sure that these cables are within proper tension. We are also checking the fluid levels on the THS system, making sure the fluids are in nominal levels, and we're doing torque checks and also lubricating the jack screw. The jack screw is the main component that makes the horizontal stabilizer go up and down for trim. By the way, that is the big massive component right there that you're seeing. Oh, another little fun fact for my Airbus pilots that fly this particular aircraft or any Airbus 320 family aircraft. Those cables that you saw don't touch any kind of flight control surface at all. It's not like a 737. You have no direct control. Those cables are going to servos. They're going to actuators. This is what makes the aircraft pure fly-by-wire. Now, to the future generations of this particular aircraft, the Airbus 321 XLR, from what I understand or from what I've read, the cables are going to be completely gone. There's going to be no more physical cables even going to servos. it's going to be pure fly-by-wire. Just to let you know, it's got nothing to do with safety. Airbus 320 family has a quadruple redundancy system. Okay, moving on. You see that little box right there that I'm zooming into? That box is housing the inlet door actuator for the APU inlet door. Now, with this angle, I was trying to capture the APU fire bottle, but I just simply could not see it. But what you can see to the right side, that big pipe, that is the main fuel line going to the APU. Oh well, we will save the APU fire bottle for another day, but right here we have access to the CVR and the FDR. On the Airbus families, they keep them in the unpressurized compartment. They are stacked on top of each other right here. These things are better known as the black boxes, like data recorder and the cockpit voice recorder. The modern day black boxes are now full digital and they are solid state recorders. And they also have underwater beacons on them. Underwater beacons are those cylindrical components right in front of it. If it touches water, any kind of water, it will send out a signal. Okay. My troubleshooting tactics led me to a dead end when I came into here, and I said, you know what, we need to go back into the aft cargo pit and start investigating more. Maybe that's where the sound is coming from. Well, we find ourselves in the aft cargo, 321. Pilot reported strange sound, buzzing sound. Let's investigate. Take this panel off and see what's actually making that sound. This is a interesting one. Dear Airbus, for the love of God, this is my plea to you. Please stop making your cargo pit wall panels and ceiling panel screws like this. Nobody likes them. They are horrible. They don't align. Oh my God, I hate these things. Here we are again. Welcome back to chapter 38, water and waste. The tank that you see onto the right side is your water tank. The tank that you see on the left side, the black one, is the waste tank. Have you been listening to the video? Have you been hearing that buzzing sound? That's what we're looking for. And now it's going to become all clear where this is coming from and why it's making that noise. This whole time, the noisy little creature was an air compressor. This poor little thing was on its last leg and basically dying. Now, in the past, I've always mentioned to you that the water supply system or the water tank is always getting some kind of a head pressure from the pneumatic systems of the aircraft. But Airbus implemented an extra little booster feature. And this is what you're looking at. This is the air supply boost system. A small little compressor that puts consistent head pressure if pneumatic sources are lacking. That little compressor is consistently supplying about 30 psi to the water tank. The compressor can work continuously to give the pressure and volume of air. The usual cycle of the compressor increases the pressure of the potable water tank to about 28 psi. If the pressure of the tank drops below about 25.5 psi, the compressor will kick on and repressurize the system. But once again, this is only active if there's no bleed pressure available. Once again, No air conditioning pressure available, no bleed pressure from the APU or the engines. It's simply there as a convenience to have pressure or head pressure onto the water tank to have water supply to the galleys as well as the lavatories. It's basically a really extra feature that Airbus implemented. It's not really needed, because if the APU is running and you have head pressure from bleed air from the APU, or the engines are running and the packs are running and you have head pressure, you're going to get positive pressure from the pneumatic system to the water system. But regardless, the system is there, the little compressor is there, and that's the thing that actually failed. Or in route of failing, because you can hear the noise. The poor thing is dying. Bottom line, we found the issue. We found the source of the problem, which was that little compressor. And unfortunately, yeah, I didn't have any parts to change it. As always, hardest working mechanic in the aviation industry goes to work. MEL, M-E-L. We had to put it on minimum equipment list. And once again, it does not affect the safety of flight. All it does is deactivates that particular component by pulling a circuit breaker. Aircraft APU is still functional. You have positive bleed air. The system is still pressurized. So basically no adverse effects, like as if it didn't exist at all. We ordered the parts. The next station, when the aircraft has downtime, they will fix it. They change it out. But yeah, that was about it. It's a pretty long-winded way of having a short day. How about that? The rest of the days of my work were pretty uneventful. Just simple ins and outs, oiling aircraft, doing basic walkarounds. This was the last airplane I worked that weekend. And then I had to fly out to Dallas, and I captured some beautiful imagery of takeoff and landing. Honestly, this was the highlight of my week. So as we were pushing back, I was flying on a 777-200, and one of the rampers right down there, he was waving because he saw me pointing a camera, but he didn't know it was me filming him. This was hilarious. But I know him, and he knows me. And he gave me the heart emoji with his hands. It was absolutely amazing. I love people who love their jobs. And I know that guy, and he's phenomenal, and he loves his job. Well, folks, that's about it for this adventure. I do apologize. It was so short and there was not much more information or context within it, but I really hope you guys liked it, and feel free to ask questions. Otherwise, I will leave you with the beautiful takeoff and the landing in Dallas. Thank you so much for watching, everybody. I appreciate every single one of you, as always. Have a good one. Stig, signing out. Later.
seat with your seatbelt fastened until the seatbelt sign is turned off. And keep the aisles clear of all carry-on items. Take a moment to check your seat back pocket for any personal items, like tablets and cell phones. When you open the overhead compartment, be careful, as items may have moved in flight. And thank you for choosing American Airlines.